All right. Hello, everyone. Can you hear me okay? Well, so nice to see again so many faces from around the world. This is the third of CS50's New Year's seminar. This one, a taste of Linux. The motivation for these seminars is indeed to give everyone just that, a taste of Linux, a taste of SQL, a taste of Python, and soon a taste of game development, all toward an end toward getting people more comfortable with these and other topics and giving you a sense of what it might be like to study programming, to study computer science, or to dive into any of CS50's courses specifically. Before I introduce today's instructor, we have a tradition of taking a group photo before we begin any of these Zoom meetings. If you would like to participate, please do turn on your camera. And in a moment, we'll go ahead and ask everyone to put on their best smile and a wave of the hand, and we're going to start taking a whole bunch of screenshots that a colleague of ours, Rung Shin, behind the scenes is then going to stitch together using a bit of artificial intelligence to detect all of our faces among all of these several hundred tiles and put together what looks like one big Zoom mosaic of us all. Right now, he's clicking from left to right through all of the pages of participants, so we need just a moment of this, and hopefully soon we'll be able to stop waving.
Awesome, thank you.
All right. Well, thank you so much. So we're thrilled to see again so many people in this seminar. We've had over 10,000 registrants from around the world. Indeed, if you look through the chat, you'll see most every city and country you might think of right now. And we have an amazing team now of over 700 volunteers who have wonderfully offered some of their time and expertise to mentor you, either here in the Zoom chat or via Ed, the course's Q&A platform. So if you have any questions today, do ask right away in the chat. And Kareem, too, will be keeping an eye out, our instructor for today, as well as on Ed after the seminar. Indeed, if you have any trouble during the seminar, technical difficulties, you get a little lost or behind or something comes up, not to worry. Everything will be freely available on the course's website thereafter, so you can work through everything again at your own pace. So it's my privilege now to introduce indeed today's instructor, Kareem, CS50's own Kareem Zidan, who joins us from far away in Egypt, where we first met him years ago via Facebook. CS50 has a very active, large Facebook group, and Kareem wonderfully started volunteering to answer lots of classmates' questions. At the time, he had worked his way through CS50 itself, and fast forward to today, he now runs CS50's IDE, or Integrated Development Environment, a tool you'll yourself use today, and continues to develop these and other tools on CS50's end. So without further ado, Kareem, welcome.
Well, thank you so much, David. And hello, everyone. Good to see everyone here today. And welcome to A Taste of Linux. My name is Kareem, and this seminar is going to be on Linux. We're going to introduce Linux and the Linux command line, as well as scratch the surface of quite a few command line tools that you'll find useful if you decided to take CS50 in the future, or even beyond that. Now, if you've never used Linux or the command line before, don't worry. We'll start from the beginning. But at any point during the seminar, if you have any questions, definitely feel free to ask in the chat window here in Zoom down below if you click on the chat button, or on the Ed discussion forum at cs50.ly/seminars/ed. Now, let me go ahead and start by sharing my slides with you. So hopefully everyone can see my screen now. All right. Cool. So the goal from today's seminar is not by any means to try and memorize everything that you'll see today, but rather to get a taste of some of the ideas, some of the concepts, some of the tools that exist, and sort of get a better sense of what's possible. One thing I'll say is when I started using Linux as my main operating system a few years ago, that I was not comfortable at all using it or using the command line. And one thing that I found to be very useful is that I simply started looking things up as I needed to. And over time and over lots of practice, I just started knowing things off the top of my head. And a lot of these tasks became really, really easier for me. So this is just something to keep in mind here. And before we dive into today's topics, I wanted to share a couple of links with you. If you'd like to have access to these slides, you can go ahead and visit cs50.ly/seminars/Linux. In these slides, you'll find a bunch of links. So you can just click on them or copy and paste them instead of having to type them out. So again, the slides are at cs50.ly/seminars/Linux. If you don't have a GitHub account, please go ahead and create one at github.com/join. You will be using your GitHub account to log into different CS50 tools including the tool that we'll be using today, which is called CS50 IDE at ide.cs50.io. So you will be able to log into the CS50 IDE using your GitHub account. We are going to demonstrate quite a few commands today. If you find yourself falling behind on some of these commands, or you just want to look something up at a later point, you can just visit cs50.ly/seminars/linux/commands, and that will give you access to a Google document that has a list of commands that we will be using today. And once again, if you have any questions during the seminar or even after the seminar, please go ahead and visit cs50.ly/seminars/ed in order to post your question, and we will try to answer as many questions as we can. I'm going to leave this slide up for quite a few seconds if you need to take any notes. All right. So let's get down to business. What is Linux? Now, most of us probably use some operating system on their computers and their laptops like macOS or Windows. Linux is yet another operating system that is free and open source. Now, even though most people don't use Linux as their main operating system on their computers, Linux is still pretty much everywhere. It's on smartphones, on cars, home appliances, servers, supercomputers, and a lot more. Linux is also used by so many software developers and system administrators in the industry, which is one of the main reasons why we are talking about it today. Now, many companies, organizations, and communities take advantage of the fact that Linux is open source and create their own customized version of Linux, also known as Linux flavors, Linux distributions, or distros for short. Some examples of these include Debian-based Linux like Debian itself and Ubuntu, RPM-based Linux like CentOS and Fedora, Pacman-based Linux like Arch, but there's so many more. Now, Debian, RPM, and Pacman all refer to the format of the software packages that you can download and install in these distributions. So one of the key differences between these distributions is how you install software in each one, but they all still share the core part of the operating system. So there's so much in common between all of them. All right. Now, just like macOS and Windows, Linux has a graphical user interface, or GUI, where we interact with the system using a mouse and a keyboard. For example, we click on things to select them. We double click on things to open them up. We drag and drop things to move them around. We have all of these buttons and all of these menus that we can interact with. But most of us probably know how to use a GUI already. So today we're going to use a different way to interact with the system, and that is the command line. So what is the command line? Again, it's a way of interacting with a software or system using textual commands. So just by using my keyboard, I will be able to type some textual commands and run these commands and achieve various tasks. But why, you might be wondering, why would you use something like the command line when we have something like the GUI that's arguably more user-friendly in some cases? And there's a number of reasons for that, but one of the main reasons is that it's more efficient and more powerful to use the command lines in some cases, allowing us to do things that cannot be done easily using the GUI, or cannot be done at all using the GUI. All right, before we talk about the Linux file system hierarchy, let me pause here for a few seconds and see if we have any questions on any of the concepts that we introduced so far. All right, so question in the chat: what is the difference between Unix and Linux? Unix is yet another operating system. It's older than Linux, and a lot of the concepts and ideas that Linux has are actually based on concepts and ideas from this older operating system that is called Unix. Unix is not used today as much as it used to be, because obviously there's more capable operating system, more modern operating systems that can be used. All right, good question. Let's move on and talk about the Linux file system hierarchy, or in other words, how the files and folders are laid out in a typical Linux system, just so we know how we can navigate the system. And it's pretty easy. So in Linux, everything lives inside of one folder or directory called the root directory. or slash. So inside of the root directory or slash, you'll find some more directories, for example, etc, home, user, opt, and more. And maybe you'll find some more files. Inside of each of these folders, you may find some more folders and some more files, and so on. So we end up with this sort of tree-shaped hierarchy for the file system, where we have folders, and then we have nested folders inside of them, and nested folders and files, and so on and so forth. But everything in the end lives inside of this root folder all the way to the top of the tree. And it's often the case that we need to refer to the location of one of these files or folders on this file tree. And for that, we use what is called a path. So a path consists of the names of the directories leading up to a particular file or directory and separated by a slash. And there's two kinds of paths. There's what is known as an absolute path, and there's a relative path. An absolute path starts all the way from the top of the tree, from the root folder, and then goes all the way down to the file or folder that we want. And it doesn't matter where we are in this file tree, it doesn't matter which folder we're in, the absolute path for the same file or folder stays the same, so long as the location of these stays the same. A relative path, on the other hand, as the name suggests, is relative to something. And in this case, it's relative to the folder that we're in right now. So let's see some examples of that just to make more sense of it. Suppose we have a file tree that looks something like this. And we'd like to get the location of mario.c using its absolute path. What is the absolute path of mario.c? Again, the absolute path starts all the way at the top of the tree. So we start with the root folder, slash. Then we pass by home, then Ubuntu, then pset1, and then finally mario.c. And so the absolute path ends up being something like /home, /ubuntu, /pset1, /mario.c. The very first slash in this path means the root directory. And then every slash after this is just a separator between the different directory names on this tree. All right, so this is the absolute path for mario.c on this file tree. Now, let's take another example. What is the absolute path of the pset0 folder? Again, the absolute path starts all the way at the top of the tree with a root directory. So slash, then we pass by home, Ubuntu, pset0, and so the absolute path ends up being /home, /ubuntu, /pset0. Great. Any questions on the absolute path so far? How to get a tree-like visualization on a Linux system. So there's a program that you can install called Tree. It's installed, I think, by default on the CS50 IDE. So if you run Tree in the CS50 IDE terminal, you will be able to see a tree-like structure on in your terminal. But we'll get to that later. All right. Another question: why don't we write root? So this is just how they decided things to be. So they decided that the topmost folder on this tree is going to be called slash, or in a human-friendly way, it's going to be called root. They could have called it root, but they just decided not to. They decided to simply just call it slash. Good question. Where do we need to type cd? We'll get to that in a moment. All right. Cool. All right, let's move on. Let's see some examples for relative paths. Now, what is the relative path of mario.c on this file tree? And we can't just say what is the relative path of mario.c. As we said, the relative path is relative to the directory or folder that we're in right now. So let's say that we're right now in the folder called Ubuntu. How do we get the relative path, or what is the relative path of mario.c from Ubuntu? And in case of a relative path, we don't need to start all the way at the top of the tree. So we just say pset1 /mario.c. Now, this also happens to be the same as ./pset1 /mario.c, dot meaning the current folder. So start from the current folder, which is Ubuntu, then go to pset1, then go to mario.c. So this is just a more explicit way of saying pretty much the same thing. All right. So let's take a more tricky example of a relative path. what is the relative path of mario.c from the pset0 folder? Now, in this case, we can't just say pset1 mario.c like we said before, and because there's no pset1 folder inside of the pset0 folder, we need to go up one folder to the parent folder, Ubuntu in this case, then go back inside of pset1, then to mario.c. But how do we represent this notation of going up to the parent folder? And it turns out the way to represent this is using dot dot. So dot means the current folder, dot dot means the parent folder, in this case, Ubuntu. So dot dot slash pset1 slash mario.c is going to be the relative path of mario.c from the pset0 folder. So once again, dot means the current folder, dot dot means the parent folder. Any questions on the relative paths so far? How do we know what current folder we're in right now? So we'll get to that later, but on this file tree, the current folder, we're representing it with this orange highlighted circle. So right now we are in pset0 and we'd like to get to mario.c. So from orange to yellow, so we end up taking this path dot dot slash pset1 slash mario.c. All right, cool. Now let's move on. Let me get to my IDE at ide.cs50.io. So if you'd like to follow along, and you're highly encouraged to do that, please go ahead and visit that URL. And I am in my CS50 IDE right now, and the CS50 IDE is basically a cloud-based programming environment, which means it's a programming environment that's living somewhere on the internet, and it's isolated, so we can use it to experiment with anything without having to worry about destroying or breaking anything on our own Mac or PC. And the CS50 IDE is running a distribution of Linux called Ubuntu Linux, a very popular distribution of Linux. And the first thing that you'll notice once you open the CS50 IDE is that it has a GUI of its own. It has a graphical user interface of its own. This is completely separate, completely different from what a standard Linux GUI looks like. This is just the GUI for the CS50 IDE. But you'll notice here at the bottom, there's this blue window that we are going to call the terminal window. And this is where we'll be spending most of our seminar today. So I'm going to go ahead and maximize my terminal windows just so we can focus more on it. And let's start by defining what is a terminal window. A terminal window, or a terminal, is simply a program that runs another type of program called a shell. All right, what is a shell? A shell is a program that just waits for a command, processes this command, and then runs it for us. And there's different shell programs available. One of the most popular ones is called bash, and this is the shell that we are going to be using today. So we are going to be using bash, which is a shell program running inside of our terminal here. And the first thing that you'll notice inside of this terminal window is this part here on the left. This is known as the shell prompt. And this is where we will be entering our textual commands for today. And this part can be customized. In the CS50 IDE, it is just configured to show us the path for the folder that we're in right now. We'll get back to what tilde means in this case. $sign is just a separator that separates the path, which is my shell prompt in this case, from the command that I'll be entering. But this is what a shell prompt is. And the first thing that we're going to do is, let's go ahead and go to the root folder all the way at the top of the tree. See what's going to happen. The command I'm going to use to do this is called cd for change directory. So cd space and then the path to the folder or directory that I'd like to go to, which is / the root folder, enter to run my command. And you'll notice here on the left that the shell prompt changed to /, show me that I'm right now in my root folder. Now, what do you think is going to happen if I try to go up one folder from here? Nothing will happen, won't work. Error, not possible. All right, all good guesses. Let's try this out. And again, this is one of the things that's good about using something like the CS50 IDE or any isolated environment, is that you can experiment without having to worry about breaking anything. So I'm going to go ahead and go to the parent folder. So I'm going again to use my cd command for change directory, then the path to the parent folder. How do I go to the parent folder? What symbol represents the parent folder? Dot dot. Correct. So cd space dot dot to say go to the parent folder, enter. And my shell prompt is the same. Nothing seems to have happened. And this is again because the root folder is the topmost folder in my tree, so I cannot go up any more than that. So in this case, nothing happens. So what else can we do with this? Let's go to let's try to explore what's in the root folder. See what the contents of the root folder are. And for this, I'm going to use a command called ls for list. So ls lists the contents of the current folder, so the files and folders that exist in the current folder, enter. And I'm going to see a bunch of entries here. Don't worry about the different colors or different symbols right now. Most of these are just folders. So let's take a few of them to talk about them. For example, the etc folder here is where system-wide configuration files would typically live. The home folder here is usually where our own files and folders would live. Let's see, the opt folder here is where third-party programs or software would typically be installed. The temp folder here is where temporary files would typically live. The user folder here is typically where some programs and some libraries that are used by these programs and by the system would typically be installed. And there's a bunch more. So many of these folders you're going to find in any Linux distribution that you end up using. Again, we're using Ubuntu. And they have a convention when it comes to what files or folders would be stored in these. So let's go ahead and go to the folder called home right here. How do I do that? So I'm going to use, again, my cd command, space, and then the path to the home folder. So cd home is one way, using the relative path for home. What's another way? So this is correct. cd home will take me to the home folder. cd/home, using the absolute path for the home folder, would also be correct. cd./home is also correct, using, again, the relative path, but in a more explicit manner. Dot meaning start from the current folder and then go to the home folder. Great. So if I do that and press enter, my shell prompt will change to /home. So now I'm inside of the /home folder. Okay, let's list the contents of this folder and see what's in there. So again, ls would do that for me, enter. And it's going to list two folders here that live in /home. Those are CS50 and Ubuntu. Let's go inside of Ubuntu. So I'm going to do cd space Ubuntu to go inside of my Ubuntu folder, enter. And you'll notice something different here. What's something unexpected that happened right now in my terminal? Tilde, yes. So this changed to tilde. And what did we expect it to change to? Ubuntu /home/Ubuntu. Yes, the absolute path for /home/Ubuntu. Yeah, that is correct. And it turns out this is because Linux can have more than one user on the system. These users, each of these users would have a username and maybe a password. And some of these users can have what is called a home folder configured for them to be their workspaces, right? So in this case, by default, in the CS50 IDE, we are logged in as a user called Ubuntu. And the home folder for this Ubuntu user is configured to be /home/Ubuntu. Now, tilde here represents the home folder of the current user, whatever the current user is. So once again, we are logged in by default in the CS50 IDE as user Ubuntu, whose home folder is configured to be /home/Ubuntu. Tilde represents the home folder of the current user, so it represents /home/Ubuntu. But let's verify that. There's another command that shows you the absolute path of the folder that you're in right now. And this command is called pwd for present working directory. Enter, and that will indeed show me /home/Ubuntu without any shortcuts. So this confirms that I am in my /home/Ubuntu folder. All right, Any question on this part? Can it be tilde/Ubuntu? This is not quite accurate. And the reason why it's not accurate is that this part, this shortcut here, tilde, is actually /home/Ubuntu. So this is going to end up being /home/Ubuntu/Ubuntu, which is not necessarily correct in our case. What is PWD? PWD is short for present working directory, and it's a command that shows you the absolute path of the folder that you're in right now, or the present folder. In this case, /home/Ubuntu, represented by tilde, which is a shortcut for it. Okay, so a bit of confusion about the folder that's called home, like literally home, and the home folder. So there's a folder in the root folder. If you go back to the root folder using cd // I'm going to clear my screen just to see things better. ls. So there's this folder. This is called the home folder /home, right? Or yeah, the home folder. And there's the home folder for a user. So the home folder for our user is going to be /home/Ubuntu, or simply just tilde. So this is the difference between what the literal home folder means and what our home folder or the home folder for the user means. All good questions. So yes, the /home folder can contain home folders for more than one user. All right. So far, so good. Let's move on. Let's go ahead and list the contents of my home folder right now, /home/Ubuntu. So I'm going to do ls again, enter, and it's empty. That's fine. We haven't done anything yet. Let's go ahead and create a file. So how can we do this? One way we can do this is using the touch command. So touch creates an empty file. So touch space, and then the name of the file or the path of the file, let's say foo, enter. Nothing seems to happen. Usually when nothing seems to happen, that means we didn't get any errors. That means all is good. So if you do ls again to list the contents once more, we are going to see foo this time, which is the empty file that we just created. All right. So this is how we can create empty files. How about folders? How can we create a folder? So for this, we're going to use another command called mkdir, or make directory. So mkdir space the name of the folder or the path to the folder that we'd like to create. Let's say we want to create a folder called seminar. Enter, and nothing seems to happen once more. No errors. That's good. So if you do ls once more, we are going to see a folder called seminar in our home folder, which is tilde. All right. Now, what else can we do with this? Let's go ahead and let's say we don't want the file called foo to live inside of our home folder. We want it to live inside of our seminar folder. How can we move this file? So for this, we are going to use a different command called mv for move. So mv, then space, then the source, the file that we'd like to move, which is foo in this case, and space, then the destination, where we want it to go, seminar, for example, enter, and nothing seems to happen. That's good. If we do ls again, foo disappeared from our home folder. But if we do ls space seminar to list the contents of the seminar folder, we are going to find it inside of the seminar folder. So once again, just ls list the contents of the current folder, ls and then space the path to a folder or the name of a folder is going to list the contents of this folder. In this case, we list the contents of the seminar folder, which is foo. Is there an easy way to move multiple files? That's a good question. So if you have multiple files, let's say we have a file called foo, a file called bar, a file called baz, and we would like to move all of them into the seminar folder, we can do something like this. So move, and then all the sources that you'd like to move. So foo space bar space baz space ... however many you have. Then at the end, we say the destination folder, and that is going to move all of these files inside of this folder. So this is one way you can move multiple files by hard coding their names. There are other ways to use like wildcards or patterns to move files that have a certain name pattern or something at once. But we're not going to go through this at the moment, but that is a good question. What is the difference between nano and touch? So nano is another command. It's a text editor that runs inside of your terminal. Touch doesn't allow you to edit any files. It just creates an empty file for you. All right. What is the difference between directories and files? So again, a directory is just a folder. So a folder can contain files or other folders. A file is just that. It's just a file that can have maybe some text or maybe some binary data like photos, videos, and all of that. Cool. All right, let's move on. Now, some of the commands that we are going to use or that we use so far, like ls, has output. So for example, if I do ls space slash to list the contents of the root folder once more, I'm going to find this output. Let me do this at the top of the screen so we see this better. So again, ls space slash will list the contents of this root folder. And by default, pretty much most of these commands is going to output or write the output to what is known as the standard output stream, which defaults to the terminal. So the standard output stream, or standard out for short, defaults to a terminal. And this is why commands like ls writes the output to the terminal by default. But it turns out we can change this. So we can have ls, for example, write to a different destination like a file. So how can we go ahead and do this? Let's say ls space slash to list the contents of the root folder again. But this time, we don't want to output it to the terminal. We want to redirect the standard out to a file called root list or root underscore list. Enter. You'll notice this time that nothing was outputted by ls to the terminal. We got our shell prompt back right away. But if we do ls once more, we are going to see a file called root underscore list. And if we view the contents of this file using a different command called cat, so cat space name or path of the file, enter, that is going to show me the output of ls. So we were able to redirect the standard output stream or standard out for ls, which defaults to the terminal, and have it write to a file instead. This is called output redirection. All right. So what else can we do with cat, the command? So if we just run cat without anything, enter, nothing seems to be happening, but it seems to be waiting on something. And in fact, it is waiting on input. So it's asking me for input. So if I type something like hello, enter, it says hello back. So it writes back to the terminal whatever I typed. If I say hi, it writes hi back. So it writes back whatever I typed to the terminal once again. And once I'm done with my input, I can just press Control D for done. And that will tell cat that I'm done entering all the input that I want. You can just exit now, and cat just exits, and we get our shell prompt back. But how can we use this with output redirection to have cat write to a file instead? So we can do something like, let's go ahead and go inside of our seminar folder for this. So cd space seminar to switch to our seminar folder. And let's use cat to create a file inside of that folder and write to this file. Let's say we do cat space greater than sign and welcome. Let's say we would like to write to a file called welcome. Enter. Nothing seems to be happening like before. But if I enter hello this time, enter. If I do hi, nothing seems to be happening. Notice that cat is not outputting anything to my terminal anymore. This is just what I'm entering. So hello, hi, nothing seems to be happening. Control D to indicate that I'm done. But if I do cat on welcome, the file that I just created, I'm going to see the 2 lines that I entered. So instead of cat writing the output back to the terminal, it wrote it to my file instead. So this is output redirection using cat. What else can we do? Let's try this again. Let's do, okay, let's pause for some question first. What does the greater than sign mean? So the greater than sign here is the output redirection operator. This means, hey cat, whatever your output is, don't write it to the terminal, but instead write it somewhere else. In this case, to a file called welcome. So this is output redirection. And it can be done for any command, not just cat, not just ls. If you have any command that has some sort of output, you can redirect this output to some other destination, like a file, for example. In this case, we redirected it to welcome. Okay, good question. Can we add text to welcome when it already exists? Let's try something out first, and then we'll try that. So let's do this again. So again, once again, if I view the contents of my welcome file, I'm going to see the 2 lines that I entered before. Let me go ahead and try this again. So cat to welcome, enter. And in this time, I'm going to write something like welcome to a taste of Linux. Enter, Control D to indicate that I'm done with my input. If I do cat welcome again, it says welcome to a taste of Linux. But something here happened that I didn't necessarily want to happen. So it seems to have replaced the contents of the welcome file, which were hello and hi from earlier, with a new line that I just wrote, which is welcome to a taste of Linux. Now, what if this is not what I want? What if I just want to append something to this file instead of just overwriting it? For this, we're going to use a different operator, the double greater than sign. So just a single greater than sign redirects the output to a file and overwrites the contents of this file. Double greater than sign redirects the output and appends to the file instead of overwriting it. So double greater than sign welcome to append to my welcome file. And let's say I'm going to type thanks for joining, enter, and then Control D to indicate that I'm done with my input. Now, if I view the contents of my welcome file, once again, cat welcome, it's going to be 2 lines instead of just 1 line. So it didn't overwrite my file this time. It just appended my thanks for joining line to the previous line that was in the file already. So this is output redirection. Any question on output redirection so far? What type of file is welcome? Is it a .txt file? Yes, you can think of welcome as a simple text file. Linux, it turns out, doesn't care that much about extensions, unlike Windows, for example. But yes, it is a text file. What does cat stand for? So cat stands for concat or concatenate. It turns out one of the other things that cat can do is that it can concatenate files together. So let's create another file. Let's create a file called baz. So let's write to a file called baz. So cat greater than sign, write to baz. And let's say, hello, how are you, for example, enter. Now I have 3 files, the file that I moved from earlier, foo, and baz and welcome. So if I cat welcome, it's going to say the 2 lines that I have in welcome. If I cat baz, it's going to say the 2 lines that I have in baz. But it turns out the cat can actually concatenate these 2 together. So if I do cat space welcome space baz, it's going to output the contents of these files one after the other, and I can then redirect them to even a 3rd file to have it write that output or concatenate that output to a file. So this is where the name cat comes from. All right, great. So this is output redirection. Let's talk about something else. So we said earlier that if we run cat here, just without anything after it, that it's going to ask me for input like before. I can say something like hello or hi, and it's going to repeat the same thing to my terminal, or write the same thing to my terminal. Now, it turns out when the command asks for input like this, and it doesn't have to be cat, it can be any command, but when a command asks for input like this, it's taken input from what is called the standard input stream, or standard in for short, which happens to be your terminal as well by default. So in this case, cat is taking input from my standard in, which is my terminal, and writing output back to my standard out, which is also my terminal by default. But what if I want to change that? What if I want cat to take input from something else, from some other source, like a file, for example? Now, it turns out we can do that as well using the less than sign operator. So cat less than sign. Let's say we want cat to read input from my welcome file. Enter. And notice that this time it didn't prompt me for input. It just read the contents of my welcome file and outputted that back to the standard out, which happens to be the terminal. So this is known as input redirection, and the whole thing is known as input output redirection, or IO redirection for short. All right, but what if I want to do both? What if I want to redirect the input and redirect the output? So we can do that as well. We can say cat less than sign welcome, which means, hey cat, read input from my welcome file instead of the terminal, but write the output to a file called welcome1 instead of the terminal. So if I do that and press enter, nothing seems to be happening on the screen. Notice that cat didn't ask me for input and didn't show any output in the terminal. But if I do ls once more, I'm going to see an additional file called welcome1. And if I cut the contents of this welcome1 file, it's going to be the exact same contents that are in my welcome file here, which is the 2 lines that we had from before. So cat, in this case, read the input from welcome and wrote the output back to a file called welcome1. All right. But as you noticed, yeah, so I see questions in the chat here. It's just a longer way to copy, right? Yeah, so this is what we ended up doing here, is we effectively copied the contents of welcome into a file called welcome1. But this is not necessarily the best way to copy a text file or to copy a file in general. For this, there is another command called cp for copy. So cp, the source of the file that we'd like to copy, so welcome, then the destination, let's say welcome2, so that will copy the file called welcome to a file called welcome2, enter. Nothing seems to be happening again, but if I do ls once more, I will see that there is an additional file called welcome2, and if I cat the contents of this file, it is going to be the 2 lines from the file welcome. So this is one way we can copy files using the command cp. All right. Something that I forgot to show earlier with the move command is that it doesn't only move files and folders, it also renames them. So let's say that I want to rename the file called foo to a file called bar. I can do this using mv space, the name of the file that I'd like to rename, foo, and then space, and then the name of the file, the new file name that I'd like, which is bar in this case. Enter. If I do ls again, I'll notice that my foo's gone and it's now called bar instead here. So this is another use case for the mv command, is that it can rename files and folders, not just move them. Any questions on any of these commands so far? What if there's a directory already with the same name? That's a great question. If there's a directory with the same name, then I think it's going to fail. But let's go ahead and try this just to see what would happen. So let's say we create a directory called foo, the old name. ls, we see a directory called foo. Now, actually, yeah, if there's a directory with the same name, it's probably going to move the file inside of the directory. So if I try to move bar back into foo, or if I try to rename bar into foo, but there's a folder called foo already, enter, it's going to move my bar file inside of my foo file, which I can confirm with ls space foo. So this is going to move the file inside of the folder. All right, good question. And yeah, definitely, this is the kind of thing that you can definitely try on your own in the CS50 IDE as well. You can learn a lot more doing stuff like this. Great. So a question in the chat here, reading the input from the file can be done with something like cat welcome. So why do something like cat > welcome? This is just for demonstration purposes for this particular command. But this can be done with any other command as well. So some commands will just take input from the standard in, which is the terminal. Cat, in this case, happens to have this feature that allows you to pass file names like this on the command line, called command line arguments, and it will view their contents. But you can find other commands that will maybe take input from the standard in and not necessarily support taking input that way. And that's when you can use something like the > sign to read the input from somewhere else, like a file. Good question. Can you create a folder if there's a file with the same name? I believe this one will fail. So if we have a file called baz and we try to make there a folder called baz, it will say cannot create directory baz, file exists. So this will fail. Can we clear our screen after some time of coding? Yes, you can do this with Control L or by typing the command clear. That will clear your terminal for you. So Control L or the command clear. All right, let's move on. So once again, I have all these files and this folder in my current folder, which is seminar. But let's say I don't really want 3 copies of my welcome file because all of these 3 are identical files, basically. So what if I'd like to remove the file called welcome1, for example? So for this, I'm going to use a command called rm for remove. So rm space the path to the file or the name of the file, in this case, welcome1, enter, and it's going to ask me, remove regular file welcome1, just to confirm. And I'm going to type yes or just Y for short, press enter. Nothing seems to happen. If I do ls again, welcome1 is gone from my folder. So I was able to remove my welcome1 folder using the rm command. But what if I'm absolutely sure that I want to remove a file and I do not want to get prompt? I do not want this confirmation. Well, I can forcibly remove a file using rm space -f or -f, and then the name of the file or the path of the file. So let's say we'd like to remove or forcibly remove the file called welcome2, enter. I didn't get prompt this time, right? I didn't get a confirmation, but if I do ls once more, I'm going to see that welcome2 is gone. So, but you have to be careful when doing something like this, when removing things forcibly, because you can end up removing something that you didn't intend to remove, which can have unpleasant consequences. So now my welcome2 file is gone, but this -f part or -f part is interesting. What is this exactly? So this is known as a command line option, or an option for short. Many or pretty much all of the commands that we're going to use today take different options. And what these options do is influence the behavior or change the behavior of this command. But how did I know about the existence of this -f option? Well, aside from Googling, it turns out that many of these commands support a special option called --help. So if I do --help, rm space --help, enter, this is going to show me a short description of what rm itself does, in this case, remove or unlink the files, how to use it, rm, then a bunch of options, then a bunch of files. And it's going to show me the options that are supported for this command. So -f or --force, ignore non-existent files and arguments, never prompt. So this is how I knew about the existence of the -f options and other options as well. Now, if you'd like a more detailed description about the command itself and about the option, you can use what is known as the man page or the manual page. So it turns out there is another command called man for manual, space, name of the command, and many of these commands will have their own manual pages. So let's say we'd like to look at the manual page for RM. So man space RM, and that will open something else, show me a description for the command and maybe a longer detailed description down here, maybe some examples, and the explanation for what each of the options does as well. So this is the man page. I'm going to quit this by pressing Q on my keyboard. So once again, rm-help will show you a short description and usage of the command. Man rm will show you the manual page for rm with more details. Cool. Let's see, do we have any questions? Can we recover removed files? In some cases, yes, you can recover removed files. We are not going to go through that today, unfortunately. What if we write man-man? So man-man is actually going to show you the man page for the man command. So this is a good question as well. So this is the man page for the man command. And it turns out man also has some options that influence its behavior and has a bunch of sections, as we see here. Section 1 is the executable programs or shell commands, and so on. Good question. When we remove a file, does it go to, using the rm command, does it go to something like the recycle bin? No, it does not go to the recycle bin. So when you remove a file using rm, it is actually removed from your computer. All right, so what about this? What if we want to do something, but we're not quite sure what command to use? So we know what we're going to do, but we don't know what command we can use to achieve it. So it turns out that man supports searching the manual pages for some keyword. For example, I can do man space -s1 -k remove. And what that means is says, hey man, or manual page, search the section 1 of the man pages, which again is for the general commands and programs that we have. There are other sections that we can search in, but they're not relevant for this. And search for the keyword remove. This is indicated by the -k or -k, and then remove. So search for the keyword remove in the section 1 of the manual pages or man pages, enter. And this is going to show me a bunch of results, as you can see here. Among these results is rm, the command that we're looking for. And it says remove files or directories. So this is a very short description for the command. It also shows something like rmdir, which can remove empty directories, if you'd like to remove an empty directory. And then there's a bunch of irrelevant commands here. So this is one way you can discover commands for doing something that you want using the man command. So the command again is man-s1 -k remove. But you can also Google how to do something, and you'll probably get some results related or mentioning some command as well. All right. Any question on man pages or any of the commands that we talked about before? What does -k mean? -k means here's the keyword that I'd like to search for. And in this case, the keyword is remove. What is -s1? -s1 means search the man pages for, search the section 1 of the man pages for this keyword. So I can search all of the sections. There's about maybe 8 or so sections for man pages. Section 1 is the section that we want for commands. But I can search all of the sections by removing this option here. So if I remove -s1, I'm just going to search in all man page sections for the keyword remove. And this is going to show me many more results, as we can see here, that not all of them are necessarily commands that we can use, but we will find if we look hard enough that rm is listed down here. How to search for a file or a directory, we are going to talk about this later. Good question. How many sections are there? I think there are 8 sections. If I do man-man, I scroll down a little bit here, there's 9 sections for man pages. So these are all the sections and their descriptions. So section 1 is the one that we want for programs or commands. Okay, so with that, let's take our first activity for today. So I'm going to switch back to my slides here and scroll down all the way to activity 0 here. Let me present that so we can see it better. So in this activity, we're going to do 4 things. We're going to create a directory called activity 0 in our home folder, tilde. We are going to change the current directory to our activity 0 directory. We are going to write hello world to a file called hello in that directory. So let's say using something like cat. Then we print the contents of the hello files to the terminal using something like cat as well. All right, so let's take 5 minutes to work on this activity. And if you'd like to look up any of the commands that we've used so far, you can go to cs50.ly/seminars/linux/commands, and that will show you a list of commands that we've used. And if you'd like to ask any questions, definitely feel free to ask in the chat or on the ed discussion forum at cs50.ly/seminars/ed. Let's take 5 minutes to work on this, and then we'll come back. All right. Welcome back, everyone. If you haven't figured that out yet, don't worry at all. It can be quite tricky at first. We are going to walk through a solution. So please feel free to follow along with us. All right, so I'm going to go back to my IDE and let's go ahead and work on this. Let's see. So the first step is to create a folder called activity0 in my home folder. Right now, I seem to be in my seminar folder, which is inside of my home folder. What's one way I can get back to my home folder? cd space ... that will take me to the parent folder, which is the home folder in this case. That is correct. What else? What's another way? cd space tilde, which is the shortcut for /home/Ubuntu, will also take me back to my home folder. That is also correct. cd/ will actually take me all the way back to the root folder, to the top of the tree. So this is different from my home folder. Just cd is actually going to work as well. So it turns out that if you don't give cd any folder, any path to a folder to go to, it will just take you back to your home folder by default. All good answers. Okay, so I'm going to use cd just for now to go back to my home folder. And if you haven't noticed, I use cd space dash or cd space minus to go back to the folder that I was previously in. So if I was previously in a folder called tilde/seminar, I can do cd space dash to go back to seminar. So this is also another nice shortcut that can come handy if you're trying to navigate somewhere else. I'm going to use cd to go back to my home folder. The next step is to create a folder called activity0. So how can I create a folder called activity0 in my current folder? Make dir, yes. So I'm going to use the make dir command, space, and then the path to the folder that I'd like to create, which is activity0. That is correct, enter. If I do ls, I can see now that I have my activity0 folder created. Okay, the next step is to go to my activity0 folder. How can I do this? How can I change directory to my activity0? cd for change directory, space, activity0, and I'm pressing tab on my the tab key on my keyboard to autocomplete. So if you just type a couple of letters from the thing that you'd like to go to and press tab, it will autocomplete for you. So cd space activity0, enter, will go inside of my activity0, and you can see here the shell prompt changed to tilde/activity0. All right, cool. The next step is to create a file called hello and write hello world to it. So how can we write hello world to a file called hello? So cat space greater than sign or operator, hello, the name of the file that I'd like to write to. So this ends up redirecting the standard out for cat to hello, the file called hello, instead of the terminal, which is the default. Enter. Cat is now going to prompt me for input. I'm going to say hello world, enter. And then how do I tell cat that I'm done? Control D to indicate that I'm done. Great, this is all good. So cat has now exited and I see my shell prompt back. If I do ls, I can see that my hello file was created in this folder. And if I view the contents of this file, how do I print the contents of this file? Cat ~sign hello or cat just cat hello. Both will do pretty much the same thing. So cat space hello will show me hello world. All right, this is great. Good job, everyone. So we were able to write hello world to this file successfully. Let me see some of the questions that flew by here. Okay. All right. Looks like some of these were answered already, so I'm just gonna move on. Cool. So what's something else that I can do? Now, here's another command that I wanted to show you. This command is called WC for word count. And if I just run WC like this, it's just going to wait for my input, just like cat did before. let me enter some random input here. So I'm going to say foo, bar, baz, quux, for example, then Control D to indicate that I'm done. And it shows me 3 numbers here down at the bottom. So if you read the man page for word count, you're going to know that the first number here represents the number of lines that I entered for my input. The second number here is the number of words. So this is some basic information about the input. First number of lines. Second number is the number of words. And the third number here is the size of my input in bytes. So this input happens to be 16 bytes long. All right. But it turns out that word count takes an option called -L to give me just the number of lines instead of everything. So if I do word count -L, enter, I'm going to enter the same thing, foo, bar, baz, quux, Control D to indicate that I'm done with my input. And it's just going to show me 3, which is the number of lines in my input. So how can we do something cool with this? Now, it turns out there's another form of input-output redirection or I/O redirection called piping. So I can do something like the following. Let's go back to my seminar folder, cd /seminar to go back to the parent folder. Then inside of my seminar folder, this is one way I can go back to my seminar folder. If I do ls again, I can see all my files here, including the file called welcome here. How can we use piping, and what is piping? If I run a command like this, let's say cat welcome vertical bar wc-l. What is that going to do? So it turns out that what this does is take the output of the cat command, which is going to be the 2 lines in the welcome file, then have this output consumed as input by the word count command. So what this is going to do is take the output of this first command, cat welcome, and then feed it as input into the word count command. And then it's going to give me the output on the terminal. So let's try this out. Enter, and it shows 2, which is the number of lines in my welcome file if I print the contents of this file again. So this is what piping does. It takes the output of one command and then feeds that output as input to another command. And you can chain more commands than just 2. So you can, if you have a command called A, a command called B, a command called C, you can chain these as well, and more than that. So this is going to run A, take the output from A, feed it as input into B, and then take the output from B, feed it as input into C, and then so on. All right, so this is piping. Any questions on piping? And the vertical bar symbol is, if you can't find it on your keyboard, it's typically near the enter key or the return key on your keyboard in a standard American English keyboard. So this is piping in Bash. So how can we, any questions that we have on piping or input-output redirection in general? What does wc-l do? It takes inputs and returns the number of lines of this input. Yeah, so you might find the vertical bar somewhere else on your keyboard. How to get the character count? That is a good question. So word count can also give you the character count. If you open the man page for word count, you're going to see a different option for this. So man WC will give you the man page for word count. What is the difference between greater than sign and the pipe? That's a great question. So we said that greater than sign, if we do cat to a file called, let's say test, for example, that is going to take the input and write the output to, that is going to write the output to a file called test. So if I say hello, enter, Control D, and then I'm going to find a file called test here, test, it says hello. Now with piping, we don't really need to create the files, right? So we can take the output from the command directly and then feed it as input to another command without necessarily writing it first to a file. So if we remember, just cat takes input from the standard in, which is the terminal, and writes it back to the terminal like this. We can do something like cat vertical bar or pipe into wc-l. Now we're not writing to any files in this case. Cat is just going to take input from my standard in, which is the terminal, like before, enter. It's not going to write anything to the terminal at this point. I do hi, how are you? No, nothing is being written to the terminal. It's just taking my input. But if I hit Control D to indicate that I'm done, it's going to show me the line count, which is 3 in this case. So it took the output from the cat, which would normally be written to the terminal, fed it as input, excuse me, into the word count program, and then word count ended up outputting 3, which is the number of lines. Yes, can we save the output to a file instead of writing it to the terminal? Yes. So you can do that with the greater than sign like before. So you can use piping and output redirection in the same command. That's no problem. And let's say out and enter hi or hey, hello. There's 2 lines, Control D. Nothing seems to be output to the terminal, but if I do ls, I can find a file called out. And if I cat out, it's going to have the number of lines, which is 2. Good question. So this is piping. What else can we do? Let me go ahead and go back to my home folder using cd or cd dot, right? And the next thing that I'm going to do is I'm going to download a file to my CS50 IDE. And the command to use is called wget. So wget is a command that we can use to download files from some URL. And I happen to know the URL off the top of my head. It's https://cdn.cs50.net/2021/x/linux/shows.csv, I believe. And this URL is also in the slides if you'd like to copy and paste it instead of like having to type it out. But if I type this URL and press enter, a bunch of output is going to fly by my screen, indicating that the file called shows.csv was downloaded successfully. If I do ls to list the contents, I can see that there's a file called shows.csv right here. So let's view the contents of shows.csv. So I'm going to do cat shows.csv. And a whole bunch of lines are going to fly by my screen here, my terminal here. And the contents of this file are just a bunch of shows, TV shows from IMDb with their IDs, their year, their episodes, and a couple more things. And this is a CSV file, short for comma separated values, which means each line is just a row consists of a bunch of fields or columns that are separated by a comma, hence the name comma separated values. All right. But this is not a great way to interact with this shows.csv file. As you can see, like it's just painful to keep scrolling up and down. What's a nicer way to interact with a file like this or view the contents of a file like this, which tends to be a big file in this case? So for this, we can use a different command called less. So less is going to, and then the name of the file or the path to the file is going to show us the file, the contents of the file, but also allow us to interact with this file in some ways, as we'll see. So for example, it starts all the way at the top of the file. So we see that the first line here in the file is just the headers for the CSV. So the first column means the ID, the second column is going to be the title, third column is the year, and so on, right? But if I want to scroll down in this file, let's say we want to scroll down line by line, I can just press J on my keyboard. So the J key, J letter on my keyboard, or press enter, J, one line, scroll down one line, J, scroll down one line, J, scroll down one line, and so on. Right? So this is how we can scroll down line by line using the J key or enter. What about scrolling back up? How can we scroll back up line by line? So to scroll back up, you can use the K key on your keyboard. So K, scroll up one line, K, once more, up one line, and so on. All right, but what if we just glance at this page and see that nothing is really interesting here and we want to jump to the next page right away? For that, we can use a different key, which is the space bar. So you can use the space bar to jump to the next page. So space bar jumps to the next page as we see. All right. What if we want to go back to the previous page? So for this, we can press B. So the B key for back goes back to the previous key. And all of these are like handy keyboard shortcuts to basically interact with this file. All right. Now, what if I want to scroll all the way down, or scroll a few pages down, but I want to go back up all the way to the top of the file? How can I do this in one step? I can do this using the G key. So if I press G, it takes me all the way back up to the top of the file. So this is how we can go all the way back up. What if I want the opposite? What if I want to go all the way down to the bottom of the file? So for this, I can use Shift G. So G takes me all the way up. Shift G takes me all the way down to the bottom. And you can see here that less is saying end, like, hey, this is the end of the file. I cannot go down any more than this. Now, don't try to memorize any of these shortcuts. I'm sure there's a list of them somewhere on the internet. If you Google less shortcuts or something, and over time and practice, you'll just start knowing them off the top of your head. But you can see how much accessible it's making this for us. So, okay, so this is G and Shift G. What about searching? What if you want to search for something in this file? Let me jump all the way back up to the top of the file using G. And let's say I want to search for the shows that have the word "the" in their title. How can I do this? If I press the / key on my keyboard, you'll see here that this colon changed to a /, and I can start typing whatever I'm trying to search for. For example, the word "the." So / and then whatever you're searching for, enter. And if it finds it in the file, it's just going to jump to it right away. So the first show that has the word "the" in the title is called Rock from the Sun. All right. How can I go to the next match? So for that, I can press N for next. So N will take me to the next match, Beauty and the Beast, N, next match, and so on. What if I want to go back to the previous match? Shift N will take me back to the previous match. So Shift N for next will take me back to the previous match. So this is how we can do searching. But if I keep pressing N here for next, N, all of these seem to match exactly what I type. Even when it's part of a word like this, like it's not necessarily the word "the" on its own, and there are ways around this, but it's all THE lowercase. It's matching exactly what I type. What if I want to search in a case-insensitive manner? What if I want to search for things that have the capital letter T, for example, in them? Let me jump back all the way to the top of the file. I can do this by toggling the case-insensitive search by pressing -I. So by pressing -I on my keyboard, it says here at the bottom, ignore case and searches. So from now on, it's going to ignore whether I'm using uppercase or lowercase and just search for the letter THE. So if I press next, and you can see that some matches started to come up now with a capital T, right? If I want to toggle this back to respect the case of the letters that I'm entering, I can do -I again, and it will say that case is significant in searches. So this is how we can use all of these keyboard shortcuts to interact with file. And there's a lot more than this that less can do. So we're just scratching the surface of less in this case. All right, so I'm done using less for now. I'm done demonstrating it. How do I quit? I just press Q on my keyboard, and that will take me back to my shell prompt in the terminal. All right, so any questions on less so far? How do I use -I? You just literally type -I on your keyboard, and it will toggle whether or not it's searching in a case-sensitive way. So when do you use Q and when do you use Control-D? So Control-D is used when a program or a command is taking input from the standard input stream, which is the terminal by default, and you just would like to indicate that I'm done entering my input. This is when you use Control-D. For less, Q is just a keyboard shortcut that Q itself is programmed to handle. So when you press Q while the less program is open, it just quits. Good question. All right, let's move on. Let's see how many lines are in this shows.csv file that we have. Whoops. So if I do wc-l shows.csv, this is going to show me the number of lines in this file. 500 lines. Wow, okay. So pretty big file. What if I just want the first few lines from this file? What if I just care about these very first few lines? So for that, there's a command called head. So head, and then the name or the path of the file, shows.csv, will just show you the first 10 lines or so from this file by default. But you can change that. I can say, for example, if I use the option -n, head-n 28 shows.csv, enter, and that is going to show me the first 28 lines from the file instead of the first 10. So once again, head-n shows.csv. And you can do other cool stuff with head and piping that we learned about. So for example, if I want to do cat shows.csv like before, it flies by. So suppose you have a command like cat that outputs a lot of lines like this, but we just care about the first few lines. I can pipe this into head. So that means take the output of this command, cat shows.csv, pipe it into head, so feed it as input to head. And it turns out head takes input from standard stream by default as well. So this is going to have the effect of show me just the first 10 lines of this file. So again, head shows you the first 10 lines of a file or of the input that you give it on the standard in. So this is head. What about the opposite? What if I want to see the last 10 lines of the files, for example? So for this, there is another command called tail. So tail shows.csv, enter, and that will show me the last 10 lines from the file instead of the last first. And I can also change this by doing tail-n 28, for example, shows.csv, and that will show me the last 28 lines from the file instead of the default 10. All right, so this is how we can use head and tail. Now, let's do something else. If we open this file in less again, shows.csv, once again, this file is a CSV file for comma separated values, and each one of these lines is following a very specific format. It has a bunch of fields or columns separated by these little commas. Now, what if I just want to see the first column of this file instead of everything? Now, for this, I can use a command called cut. So cut allows us to select specific fields or columns from files and print them out. So I'm going to do cut -d, comma, to specify that, hey, these fields or columns are delimited or separated by commas, right? -f for the field that I'd like to select, or the fields that I'd like to select, plural if you want, 1, so I want to select the first field from shows.csv. So again, what this is going to do is select the first field from the file called shows.csv and separate these fields by comma, or like deal with these fields in a way that they are separated with commas. All right, so if I do this, and I hit enter, it's just going to show me a bunch of IDs. All right, and I can do this on any column in the file. So if I do, for example, cut -d comma, because these fields are separated by commas, -f for field number 2, it's going to show me just the name of the show, because the name of the show is the second column in this file, right? So this is what cut can do for us. So any questions on cut so far? Do we need the comma after the -d? Yes, you need the comma after the -d, because I believe by default, cut thinks that the delimiter or the separator is space. So you'll need to specify something other than the default, which is in this case comma, but it can be anything else if you have anything else that separates these fields. Is grep like cut? We will talk about grep in a second. How do we output more than one column? That is a great question. Suppose we want to output the title of the show and the year of the show, which is, if we do this again, shows.csv, we see that the title is the second column and the year is the third column here, 1, 2, and 1, 2, 3. All right. If I do this, I can do cut minus the comma, separate by commas, minus f 2, 3. So print the second column, second field, and the third field from shows.csv, enter, and that is going to show me the title of the show followed by the year, as we see here. All right. So this is how we can output multiple fields. What if the fields are separated by space or a tab? You can specify this as well. So you can say cut -d space. I think space is the default, but if you want to be more explicit about this, you can say -d space. And notice that I put it in between single quotes here, so that bash respects that there's a white space here. Otherwise, it's going to be ignored. So if you have any white spaces or special characters in your command, you're probably going to need to surround them with single quotes or double quotes. And that's a good thing to know as well. All right, and I can do more cool stuff as well. Like if I do this command again and I pressed up arrow on my keyboard to scroll back to the previous command, if I press up arrow again, I can scroll through the command and back down. So this is a handy keyboard shortcut to use as well if you'd like to enter a command that you entered previously without having to type it out again. But I can do something like, pipe it into head to show me just the first 10 lines of this output, or pipe it into tail to show me the last 10 lines, and so on. So this is what I can do with cut. All right, so what else can we do? I don't like the fact that if I open this again in less, that these IDs seem to be randomly sorted. Is there a better way to sort these IDs? By their values. And for that, we are going to use a command called sort. So sort sorts the contents of a file by line by line. So if I do source shows.csv, enter, it seems to have worked, but not exactly how I wanted it to work, right? So it seems to be sorting, but it's sorting, all 7s first, and then all 8s, and then all 9s. And I'm sure if I look back up, it's going to be all 1s, then all 2s, all 3s, but it's not necessarily respecting the numeric value of this string, right? So you can see that smaller numbers are coming after bigger numbers. And this is because, all 0s come before all 2s and so on. But what if I want to sort this the way that I want, which is, by the value of this number? So if I look at the documentation for sort, or the manual page for sort, I can do sort -n for numeric, shows.csv, enter, and this is going to sort it the way that I expect with respect to the numeric values of these IDs. So this is how sort works. And notice if I open the file again, shows.csv and less, that it's not sorted. So by default, sort does not change the contents of the file itself. It just writes the output, like other commands, to the standard out, which is the terminal by default. If I want to remember these results, if I want to remember the sorted output, what do? How can I remember this in a file? Greater than sign. So this is going to redirect the output of sort. Hey, sort, don't write the output to the terminal anymore. Write it to a file called shows_sorted, for example, .csv. Enter. And this time, sort did not write any output to the terminal. It instead wrote everything to shows_sorted.csv. If I open this file, shows_sorted.csv, that is going to show me the sorted output, as we see. Great. So this is sort. Any questions on sort or cut or any of the previous commands? Sort only source based on the first column. You can specify what column you want to sort by, I believe. I'll let you explore this if you open the man page for sort. I'm sure you'll find some option that that can help you specify the key to sort by instead of just by the first column or by from the start of the line to the end of the line. Can we sort in descending order? Yes. If we open the man page for sort, you are going to find some options that will allow you to sort by reverse. So -R here, reverse the results of the comparisons. So all of these options, all of these cool options, you can explore from the man page for sort as well. All right, so this is sort. What else can we do? What if we want to search for something in this huge file without necessarily opening the file and scrolling through it? We can do this using a command called grep. So grep is going to search for something in a file or in the input, and then output any matching lines. So let's say I want to search for the show Friends. So Friends in shows.csv, enter, and it's going to show me the row that matches my search term, which is Friends. If there's more than one row, it's going to show these one after the other. All right. But notice if I do grep Friends with lowercase f this time, enter, it's not going to find anything. And this is because, again, by default, searching is case sensitive. If you want to ignore the case of the letters, we can do grep -I friends shows.csv, enter, and that is going to find me the same result from before. All right, so -I for grep ignores the case for the search. What if I want to search for something that's more than one word? I can do this grep -I, let's say Game of Thrones, and notice that I surrounded my search with quotes here, because I want Bash to treat this as one thing to search for, right? So again, if you have spaces, if you have special characters that might confuse your shell, you might need to surround these with single quotes or double quotes to get around that. So in shows.csv, it shows me that the line that matches Game of Thrones in my file here, as you can see. Now, it turns out we can search using regular expressions using grep as well. So we're not going to go through regular expressions in this seminar, but you can say something like, you can provide a pattern instead of the exact thing that you'd like to search for. So let's say I'd like to search for anything that starts with 28, right? In the file called shows.csv. So this caret symbol in regular expression, if you're familiar, means, anything that starts with the following, which is 28 in this case, enter, and that is going to show me all the lines that start with 28. So these, you can use regular expressions with grep. You can use regular expressions with less as well. When we search for something in less earlier, to search for a pattern and not necessarily an exact match. All right, any questions on grep so far? Does the 28 have to be, the caret 28 have to be in quotes? I don't think it has to be in quotes in this case, but again, like just as a good practice, you can surround your arguments with quotes or single quotes or double quotes in case they have any special symbols or spaces, just to be safe that you don't confuse your shell and it doesn't break. All right. It's probably a good practice to always use spaces, or to always use spaces, just for the sake of consistency. I just omitted it earlier from the search term just for simplicity, but yeah, these two are going to work the same. Or if we do dash I. So yes, you should use quotes just to be super sure that nothing is going to break your command. All right, great. What else can we do? Now, let's script for another show. Let's grep for Seinfeld, for example. So I'm just going to enter part of the search, enter, and it's going to show me the line that matched Seinfeld here. But I noticed that there's a typo here. How can I fix this typo without opening this in a text editor and fixing it? So it turns out there's a command for this as well, and this command is called sed. So sed is one of these commands. The use of sed can be quite overwhelming, can be quite complicated. So that's okay. You can just look stuff up as you need to, but we can do something like s/Seinfeld, which is the misspelled version of this, with Seinfeld, which is the correctly spelled version of this, then / then shows.csv, and that is going to have the effect of replacing this misspelled match Seinfeld with Seinfeld, which is the correctly misspelled one. And let's pipe this to grep just so we see if that fixed it. So grep-i sign like before. So that is going to take the output of this sed command and pipe it as input into the grep command, and it's going to show me the match. And you can see here that it is fixed in this case. But if we grep for Seinfeld again in the file itself, it's still going to be misspelled. So this did not change the contents of the file. How can we fix this? How can we fix the file itself? So it turns out that sed takes an option -i that essentially allows you to search and replace or find and replace in place, which means in the same file. But yes, as people are noting in the chat, we can also do something else. We can do sed, same command from before, right? If I do this, sed Seinfeld with Seinfeld from shows.csv, it's going to show me the whole file, but with the fixed Seinfeld. But I can redirect this to another file called shows_fixed, for example, .csv, using the greater than sign, the redirect operator. Enter, and that is not going to show anything on the terminal this time because presumably it's stored in the file. If I grep for sign in this fixed.csv file, shows_fixed.csv file, it's going to be fixed, as you can see. And now if I want to overwrite the original file, I can just do mv shows_fixed to shows.csv, and that will end up replacing my shows.csv with the fixed version. But there's an easier way for this particular command, sed. It turns out sed can do all of this for us if we just use the -i command. So if I do sed -i or -i s Seinfeld with Seinfeld / in shows.csv, that means fix in place in the same file. Enter, and it didn't write anything to the terminal this time, like before. But now, if we grep for Seinfeld in our shows.csv, it's going to show the fixed version. So this is how we can use sed to fix or change anything in our text files. This is one of the things that sed can do. It can do much more than that. And we can use regular expressions with sed as well to replace certain patterns instead of exact matches. So any questions on sed or grep or any of the commands that we used? All right, great. Now I noticed that one of the things that I kept doing is write, grep-i, because I just don't care about the case for now, and I want to ignore the case. But it turns out that you can create an alias for some command. If you have maybe a long command or a command that you keep typing over and over, you can create a shorter alias for this command using the alias command. So there's a command called alias, and then the alias that I'd like to create, so igrep, for example, equals, and then in quotes, grep minus I. So what this would do is, in this terminal window, in this terminal session, whenever I type igrep, it will actually do grep-i for me, right? Enter, nothing seems to be happening. But if I do igrep on Seinfeld, like before, in shows.csv, this is going to run grep-i for me and find the match that I'm looking for. Now, this doesn't persist. If we close this terminal window and then open a new one, for example, it doesn't persist. But there are ways to persist that I'm not going to go through now. But just know that you can create these alias commands to make things easier for yourself. All right. Cool. So this was alias. Like I said before, if you press up on your the up arrow in your keyboard, you will end up scrolling through the previous commands that you entered. And if you press down, you will scroll down through these commands as well. But it turns out there's a command called history. So history is a command that shows you your command history, just that. So if I hit enter here, it's going to show me all the commands that I entered so far. And of course, you can pipe that into some stuff. So history, head to see the first 10 commands that I entered today. History tail is going to show me the last 10 commands that I entered today. And I can grep through these if I want to pipe into grep. So this is what you can do with history as well. Now, let's come back to a question that was asked in the chat before. How do we find files and folders in our system? So suppose we're looking for a file. We want to search for a file. How do we do this? For this, there's a command called find. So let's say we would like to find a file called cs50.py somewhere inside of the /user folder. So we're going to say find /user minus name. So find inside of the /user folder the file that is called cs50.py. Enter. And it's going to take some time to look through all the folders inside of the user folder and look through all the files. And then it's going to print any matches for the locations of the files that I want. So in this case, I found the file called cs50.py and it lives at this path right here. You can also use patterns with this. So you can say, show me all the files or folders inside of the /user folder that start with cs50 and then have anything after that. So cs50 followed by anything. All right, enter. And that is going to show me quite a few matches as well. So there's a file called cs50.h, there's a folder called just cs50, there's a file here called cs50.py like before, cs50.jar, cs50.c, and so on. So this is how we can use find in order to find files and folders in our system. All right, any questions on find or any of the commands before it? Why use star instead of caret? So in this case, it's a wildcard. I don't think this supports regular expressions per se. It just supports a special case of pattern matching that is different from regular expressions. Does it actually support regular expressions? I don't quite remember, to be honest. So let's say anything that starts with CS50. Yeah, I think this is literally going to try to find something that starts with caret CS50, which we don't have in this case. What does minus name stand for or do? This is an option to the find program that specifies the name of the thing that we're looking for. So for example, in this one here, minus name cs50.py means, hey, find, search for the file called or folder called cs50.py inside of my user folder. So this is what minus user, minus name means. Can we use double quotes instead of single quotes? Yes, you can use double quotes instead of single quotes. In Bash, there is a difference between double quotes and single quotes, but we're not going to go through this now. But in pretty much most cases, it's the same, but there's a difference between them. Can you find and then pipe? Yes, you can find and then pipe. You can run any command and then pipe the output to some other command. Yes. In an alias, can we do a shortcut for an actual command? Yes, you can do that, but you will end up overwriting the command itself that you're trying to run. So you'll have to do something else that's maybe a bit more complicated to reference the command itself that you're trying to run, like use the full path for the command in order to run it. Otherwise, it's just going to, maybe loop or something. All right. So this is it for find. Let's take our second and final activity for the day, activity 1. And in this activity, we are going to do five things this time. We are going to, like before, create a directory called activity1 in our home folder, tilde. We're going to change our current directory to our activity folder, activity1 folder. We are going to download this shows.csv file, maybe using something like wget. And the URL is here in the slides if you'd like to copy and paste it instead of having to type it out. Then using a pipe, we are going to print the year that Mr. Robot aired in to standard out, so the terminal. Then number 5, and the last step, we are going to find a file called libcs50.a inside of the user folder, /user folder. So where does that live inside of the /user folder? So let's take 10 minutes to work on these 5 questions, and we'll come back to wrap up. All right. Welcome back, everyone. If you're still working on this, or you can't get your commands to work, or you haven't figured it out, it's quite okay. We're going to walk through a solution right now. So please feel free to follow along with us. All right, so let me switch back to my IDE. And then let me do this. All right, so the first thing that we need to do is to create a folder called activity1 in my current folder. So I seem to have lost that chat window here. Just 1 second. Okay, there it is. All right. So the first thing that we need to do is create a folder called activity1 in our home folder. If we're not in our home folder already, we will need to switch back to our home folder. That's one way to do it, and then create a folder. And we can do that using CD. I just happen to be in my home folder right now. So how do we create a folder called activity1 in our home folder? Mkdir, we're going to use the mkdir command, space, path of the folder, or name of the folder, in this case, activity1, just one word, right? Enter. Let's list the contents of this folder to see what folders are in there, or files. How do we do this? What command do we use to list the contents of the current folder? ls, that's correct. So ls shows me that I have my activity folder here. All right. How do I change to the home folder, to the activity1 folder? Okay. Change directory to activity1. All right, that is correct. Now, ls, nothing is in there. Now, what's the first step? We need to download the file shows.csv from the CDN URL. What command do we use to do this? wget. So wget and then the URL of the file, hbs:// cdn.csv.net ... But let's do something different here. I know that I downloaded this file before inside of my home folder. It's called shows.csv right here. It's pretty much exactly the same file. What if I just instead want to copy this file from my home folder to my activity1 folder? How can I do this? I can use the cp command. So cp, and then the file that I'd like to copy. What is the file that I'd like to copy? What is the path to the file that I'd like to copy? So /activity0/shows.csv. So it turns out that actually my shows.csv is not in the activity0 folder, it's in my home folder. So this is, you're very close. All right. So I can do something like tilde/shows.csv, or I can do ... because tilde is a parent folder, /shows.csv. This will also do the same thing. I meant to do cp instead of cd. That's a typo. So cp starts for copy, and then the destination. So I want to copy this file in this folder. How do I say I want to copy this file in the current folder? Dot. So dot represents the current folder, ... represents the parent folder. So I want to copy shows.csv from the parent folder into the current folder. Press enter. If I do ls once more, I can see that I have a copy of shows.csv in my activity1 folder right now. Now, dot and / are the same thing. This slash is just used as a separator, and it's optional in this case. So this will also work. All right. Okay, what else? What's next? We need to get the year, or print the year that Mr. Robot aired in to the standard out, to the terminal. How can we do this? Let's do this step by step. How can we find Mr. Robot in the file, shows.csv, without opening the file? What command do we use to do this? grep. So we can do grep. We can either ignore the case, or if we know the case exactly right, we can just say Mr. Robot, which matches the exact case in the file, from Yep, the file called shows.csv, enter, and that will print the matching line to the standard out with a match Mr. Robot. Great. Now, we don't need the whole line. We just need the year, which is column 1, 2, 3. So column 3. What command do you use to select the third column or field? We can use cut. So we can pipe the output from our command, the grep command, into cut. So feed it into cut as input, minus d, that the limiter is going to be comma, because comma, this is comma separated values line or row, right? Then we are going to select field number 1 to number 3. So field number 3. All right, so this is going to get the output of the grep command, which is this line over here, feed it as input to the cut command over here, separate the columns by comma, and then print the value of the third column or field. And the end result is going to be 2015, which is the year that we care about. All right, awesome. Any question on this pipeline or any of the commands before that? Now, the last step is going to be to find the file called libcs50.a inside of /user. How can we do this? What command do we use for this? Let me answer this question first. Why grep-i Mr. Robot? You can do grep-i Mr. Robot like this from shows.csv, and that will show you the same thing. Notice here that I didn't have to exactly match the case for these letters, so I just used lowercase instead and ignored the case in the grep search. So this is also correct. And then feed that into cut like before to get the year. Good question. All right, and yeah, like everyone is saying, the command to use to search for a file is called find. So find, and we'd like to search inside of the /user folder. So find in /user, the file that is called libcs50.a. So minus name specifies or says, here comes the name of the file that I'd like to search for. Enter, and that is going to take a second, and then it's going to show us the location, the absolute path for the CS50 library inside of our IDE, which is /user/lib/cs50.a. Any questions on find or any of these commands? Cool. Let me go back to my slide here. And before we wrap up, I wanted to share a couple more links with you. You're definitely more than welcome to keep using the CS50 IDE to experiment with anything you want. Again, the CS50 IDE is running a version of Linux or a distribution of Linux called Ubuntu Linux. But the CS50 IDE is restricted in quite a few ways because it's, at the end of the day, designed to be used for CS50 or courses like CS50. If you'd like to use a more complete version of Linux or Ubuntu, feel free to go ahead and visit this link, ubuntu.com/appliance/VM. You will be able to download a virtual machine image. So you can essentially run a virtual computer. You can think of a virtual computer inside of your computer that has Ubuntu Linux installed on it. And you can experiment with all of these commands and more. So the URL, once again, if you'd like to take a note of it, is ubuntu.com/appliance/VM. And the next link that I wanted to share with you is a tutorial for command line for beginners. So this tutorial is going to include information or details about some of the commands that we talked about today, and maybe more commands, and it's going to have maybe some examples like the ones that we did today, and maybe more examples. So if you'd like something like this in a written format, you can go ahead and visit ubuntu.com/tutorials/command line for beginners. And there's a nice tutorial there that you can check out as well. All right. Once again, definitely feel free to check out the CS50 courses on edX at cs50.edx.org. All of these courses are free of charge, so you can sign up and audit the courses completely free of charge. There's some cool content in there, so definitely feel free to go ahead and check that out. Again, cs50.edx.org. And if you don't mind giving us feedback on this seminar and the other seminars as well at cs50.ly/feedback, we would greatly appreciate your feedback on these, and it would help us improve these in the future as well. So the URL again is cs50.ly/feedback. We would greatly appreciate that. All right, that was it for a taste of Linux. Thank you so much once again for joining, and we'll see you next time. Thank you.